Okay, so Trig, we've arrived at a weird spot because this year we had 5-day-a-week Trig instead of some years it's 4-day-a-week Trig. So we're in a part of the year that is new, never been happening before, that I'm calling miscellaneous things from your past. So today is Shapes Day is what I'll call this. So we're working from a sheet that says Geometry Quiz 2. That once upon a time when you were in geometry you would have done this very quiz and demonstrated your knowledge of shapes. So if people can do them, let's just kind of spontaneously do these shapes, and if we hit shapes that you can no longer do, we'll take a couple seconds and someone will just yell help, and then I'll just either draw it on the board or talk about it. One, anybody confidence in your perimeter?
20.
It is 20. If you've completely blanked out on perimeter, the concept of perimeter is add your way the whole way around the shape. Every number around the outside, whether it's labeled or not, you add them all up. So that has a whole bunch of 5s. I only wrote a single 5, but 20 is the perimeter. 2, a thought, is 25. The idea of area is the space inside. Generally speaking, you multiply two numbers that are perpendicular to each other, two numbers that form a right angle with each other. On this, it would be a 5 times another partner 5, because a square, they're all the same 5s, so 5 times 5 is 25. 3 is 26. 4 is 42. 5, dotted gets used for area only. Dotted never gets used for perimeter. Anything that goes dotted through the inside is part of the area math, but never part of the perimeter math. 38 is perimeter for 5. 80 is area for 6. Slight hint on number 7, you're going to have to draw in your own dotted line. So the same position I just drew the 8 for you, you have to draw in a dotted line and use another geometry fact to know how long that dotted line would be.
Is it 120?
The grand total is 120. How long is the dotted line itself?
6.
6. Why is it 6?
Because
It's half the 30. The 30 angle makes it be half of the 12. So we draw in a 6 and then we math it up to get 120. 8, I drew you your dotted line, but I didn't label it. How can you generate the dotted line from the 10 and the 26? It is 24. How did you know that so quickly? It is a 5, 12, 13 Pythagorean triplet that I just doubled. So it is a 24. If you forget the triplets, you could square to get a leg, subtract and root. But dotted thing is 24, so then do math.
720.
720 is a win. 9, 10, 11, 12, what do you have to be always suspicious of triangles about? For which part? Area cuts in half. So area triangles, we've got to do it cut in half. 9 math
24
is 24. 10's math
27.
27. 11's math
24.
24. 12's math
24.
also 24. I'll slow down for a second. If you've mastered the first 12, why don't you go work ahead on to 13 to 25 while I'm talking to other people. And if you didn't master the first 12, let me help you. What will happen tonight, I'm going to give you an exact matching worksheet, which is like probably quiz 3 or some other number that is a perfect match for this. Someday when we take the test on this, like the finals day of school, you'll get this exact page back, but it'll be probably like version 4. If you're in 12th grade, you don't care about the test. You're gone by then. If you're in 12th grade, you're just worried about like being able to do the homework off of this. But juniors would face a quiz and then one day a test. Anybody first 12 need me to fill in more details than what I filled?
Where do you get the dotted on 8?
Dotted on 8, look at the 26, the 10, and the dotted as a right triangle, which brings the Pythagorean theorem into play. So you could either remember your triplets, that one's a 5, 12, 13, I just doubled them all. Or you could square the 26, subtract the square of the 10, and then root it, and that could work. Square, subtract, root could get you the leg. Anybody else need more rundown on how to do that first 12 column? 13, I'll drop you the hint, it involves subtraction.
AB minus XY.
It is AB minus XY, that's true. 14 is going to involve either remembering a formula for trapezoids that you probably forgot, or more likely, draw in a dotted thing at the corner where the 10s touch, and kind of do it in a rectangle and a triangle piece. 15 is a similar thing. I drew you in one dotted line. You probably want to draw me in a matching dotted line, like toward the left where the 30 is. Do a bunch of Pythagorean theorem kind of things on 14 and 15 to get the dotted sides and the missing sides. It's probably easier to do 14 as one rectangle, one triangle. Probably easier to do 15 as one rectangle and two triangles than it is to like try to remember a trapezoid formula. It's probably long gone. Anybody 14 have confidence? It is 84. 15 is going to be over 500.
540.
It is 540. 16, circle life. Splotch up pi, get you moving a little bit.
49 pi.
It is 49 pi.
Oh, you could just write it like that.
Uh-huh. I would. 17. 14 pi. 18.
36 pi.
36 pi. 19. 12 pi is true. 20, drop you a little hint. You have to figure out the missing pieces first. I would look at anybody moving across as being part of an across team. So if you look at some of the across numbers you do know, you can figure out the across number you don't know. Likewise, the vertical numbers you do know can give away the vertical number you don't know. And once you know all the numbers, perimeter you add everybody. Area you'd make a cut, and there's a couple cuts you could make, but you'd cut it so it becomes two rectangles instead of like a weird shape. If done correctly, perimeter is in the 30s. It is 34. Area, if done correctly, is in the 40s.
49.
It is 49. Volume, basic reminder is it's the space inside of a box. You multiply three numbers together.
160.
It is 160. 23, surface area is all of the areas of all of the faces of all of the rectangles added up. So what you're going to have to do on 23 is an area of this triangle, or an area of one rectangle face, an area of another rectangle face. There should be three different faces you could figure out. And then what I prefer to do is double it because every face has a twin. But we're trying to come up with the grand total adding up every rectangle face of all six faces of this box. It's over 100, pushing 200.
184.
It is 184. 24 is the same, just all the numbers are the same, which for surface area you've got six identical like hextuplets.
729.
729 is a win.
486.
486 is a win. If you have achieved domination up to 25, go ahead, flip to the back and get a head start on what we're going to. If you've not achieved domination, let me help you achieve your domination on the group to 25. Anybody need help with any of those?
14.
14. So the dotted thing. So I'm going to draw a dotted thing right there. Since this is a 10, that's my hypotenuse. This 10 would be matched by another 10 by these matching. It's just a coincidence that was a 10, but those have to match. And then since the full bottom was 18, this is the other 8 of the 18 for 10 and 8 to get like separated. Then I want to get this leg, I'm going to go 6, thinking 3, 4, 5 triplet. I just doubled everybody. But if you're a little dicey on the triplets, square the numbers, subtract every.
Okay.
You with those numbers?
Yeah.
Then this rectangle would be 60 from 6 times 10. This would be a 24 from 6 times 8, but cut in half triangle place.
Okay.
Good enough?
Yep.
Do you need anything on 15, which is kind of similar. It has 2 triangles on each end instead of 1 triangle.
No, that one I think the line helped.
Okay.
So I could get that.
All right. Anybody else need help up to 25 to achieve domination?
23.
23. We're going to go 8 times 4 is 32, and just jot that down. Go 5 times 8 is 40, jot that down. I don't think I said 4 times 5 yet is 20, jot that down. But there's 3 different kinds of rectangles I can make from just this times that, get the different pairs you could do. So I got a 20, a 32, and a 40. You with that? Add those up. And then just go times 2, because every one of those rectangles has a buddy. Do you understand how they each have a buddy?
Yeah.
Anybody else help achieving domination up to 25? Okay. 26 is just a Pythagorean theorem, but it's not 13. Even though I'm trying to bait you into 5, 12, 13 triangle, why is it not 13? Get in the wrong place. The 13 would have to be the hypotenuse, so you've got to do just a process of what? Square, subtract, root. It's a root that looks like it might simplify, but it won't. It's going to be a messy root.
10.91.
I'd rather see it in root form. Root of whoever. I'm generally anti-rounding. Most of the math community, I think, is anti-round. When I go as my role as a science teacher, I have to round because science people are.
Root 119.
Root 119 is perfect. 27 will be a whole number, which means you could do triplet play to get it if you remember your triplets, or you could just trust the process and it'll be fine. It is 50. What were the triplets? I already said a couple of them. 3, 4, 5 is the most famous. 5, 12, 13 is up there. 7, 24, 25 is kind of obscure. 8, 15, 17 is kind of obscure. 28, do the process. It's a root that does simplify. No, it won't be like an even. It's going to be like this root that. Kind of
Wait,
stuff.
for which one?
For 28.
Oh, for 28, root 50, or 84.
Root of 84 is pretty good, but it simplifies. 2 root 21 is the money answer. Let's skip down to 43, 44, 45, because that's the same idea of simplifying roots. So if anybody just struggled with that root 84, getting down to 2 root 21, see if we can manage 43, 44, 45. Let's do like a 15-second wait time to just give people an opportunity if they're not the quickest draw. Shot
2 root 6.
is 2 root 6. Anybody need help with 2 root 6? Anybody want a wait time for 44? Can somebody hit it?
4 root 6.
4 root 6. Anybody want wait time on 45? Hit it? 10 root 5. Anybody need a run of that math seminar, how to make those happen? And pop up to 29. So 29, we encountered our friend the 30 angle again that we encountered on the front. So what was up? Somebody other than Nicole who told us. What's up with the 30 angle? What's that cause? When there's a 30 angle, what's it do in triangle life?
Like, the one side's double.
The one side's double or half, depending on your point of view. So on this one, across from the 30, I put a 5. So somewhere there's
gonna be a 10.
either a 10 or a 2.5. In this case, there's
10.
a 10. Where's the 10?
On the right.
on the right. The hypotenuse would be a 10, because the specific rule is that the side that's opposite the 30 is half the hypotenuse. So side opposite 30 is a 5, hypotenuse is a 10, and then there's a little bit of geometry trivia that gets you the other leg. Anybody remember the other leg, how to get it without the fuss of the Pythagorean theorem, which would work if you like blanked on this trick. The Pythagorean theorem would bail you out, but anybody remember? Close. 5 root 3. We'll just multiply by root 3. So left side is 5 root 3, hypotenuse 10, and then let's move over to 31 using the same trick. So 31, I give you different positioning. I give you hypotenuse is 6, so somewhere there's a 3, which is on the left. So what's the bottom? 3 root 3. So then let's go to 33. It's the same like relationship, I just gave you a different number. I'm giving you the 8 root 3. So somewhere there's got to be an 8. Where's the 8?
Bottom.
Bottom. So what's the hypotenuse?
16.
16. Then I'm kind of mean on number 35. No, wait. That one's not a mean one. Usually there's a mean one. This doesn't have a mean one. I'll do a mean one just so you have one, because the homework might have a mean one. 35 is a nice one. I spotted you the 24, so hypotenuse is easily 48, and the bottom is easily 24 root 3. That was me, probably sat down and made 10 of these sheets in one day, and I just lost my focus for a problem. I'm sure I wanted 35 to be a meaner one. So here's a meaner version of, instead of opposite the 30 putting the 24, I'm going to put the 24 there. And that's kind of like mean. Is that still on? Did you fix it for me?
I'm trying to.
Earthquake.
There we go.
All right. So a minute ago we had like a 5 and we created a 5 root 3. When we moved in this direction, what were we doing? Multiplying. So if I want a reverse field, you're going to have to divide. So if I do a mean problem, we'd have to have 24 dividing root 3. That's just not an acceptable way to write that answer because it has a root on the bottom. So somebody step into your math factory.
24 root 3 over 3.
Okay.
Which, yeah, 8 root 3.
8 root 3 is best answer. So you would multiply bottom by root 3 and top by root 3. So it would be 24 root 3 on top of regular 3. But then the regular numbers can divide. So 8 root 3 there. And then this is an easy hit.
16 root 3.
That would be a 16 root 3. It's not a problem on that paper, but I'm positive from having done like a dozen of these papers in my life, I meant for it to be there. That one's just flawed. Something there. Then a different pattern. So different pattern if there's a 45 angle. So look at number 37. If there's a 45 angle, what happens?
2 sides are the same.
2 sides are the same. Which 2 sides?
The legs.
The legs. So 37, the other leg, the left side must be 6. Then what's the hypotenuse?
6 root 2.
6 root 2 is correct. Let me skip to 41 because it's easier. On 41, I gave you the 13 root 2 hypotenuse, so not too bad to figure out the legs are each 13s. And then 39 is the mean one, and I didn't mess up that mean one. For 39, I put the hypotenuse not having a root 2 on it, so we'd have to do the same like little math steps here. Instead of 24 dividing root 3, it would be 10 dividing root 2. And then we're going to have to fix that. What are the legs going to be?
5 root 2.
5 root 2 both ways. So homework tonight will be basically just replicate what we did. Someday on a test for juniors, we'll replicate what we did.
I'm loving this.
Anybody, anything I can help you to dominate that? So let's shut that down.